Okay, so now we're live. There's me. And so I don't know what the Oregon laws are. At this point, the configuration is the video can only see me and hear me. I don't know if I'm allowed to record you all. So only speak up if you're comfortable with being on the video, okay? So the question says, oh, that's terrible. That's still terrible. Wow, I just can't win. Okay.
Luckily, we don't need to see you on the video on the screen.
I'm going to keep it just for the YouTube because I think people might watch it afterwards. So yeah, I mean, I guess I'm not a huge part of this experience, but I'll still do it. Yeah. There's a person there. Yeah. So good. Let's see. So I'm going to make a struct, and I guess we'll just call it shape. And so if we have a struct called shape, and if we have a pointer to a function which is getArea, the question is what's really happening here, right? And because there's this magic that I can make a shape, and then I've got this syntax that looks an awful lot like the syntax, if you're familiar with C++, looks an awful lot like C++ syntax and syntax from other languages, where this is a so-called method call, right? So the difference between, so what we're doing is we're doing so-called structured programming, but there's something else called object-oriented programming. And the idea with object-oriented programming, so this is C, and this is C++. And when you have structured programming, when you call a subroutine, you call it a function. It's not associated with an object. And when you're an object-oriented program and you call a function that's associated with an object, that's a method, right? So a method is a function associated with an object. And this is, and so if you have, and in Python, you guys did some object-oriented stuff. And so, maybe you've heard the word method before, but this is looking a lot like a method called a function associated with an object. So what exactly is going on here? So what's going on here? If I did this, I think you might be slightly more comfortable. If I had double star, so this is a pointer to a function pointer, and then I said function pointer equals S getArea, and then I called function pointer you might feel slightly more comfortable with that, right? So I have a function pointer, which you all dislike, and then what I'm doing is I'm setting the value of that function pointer. I'm setting the value of that function pointer equal to a data member. And that's what it is. It's a data member. Here, let me do something else. If this struct has an integer called x, and I make an integer called y, and I set y equal to sx, I'm hoping you all feel good about these lines between the comments, right? I have an integer, and I'm setting another integer to be equal to, this data member, the x data member. This is the same game plan with the pointer functions, right? And in the same way, where and what you see in the code is you're seeing this. The area is, and then it's s dot getArea. Right? And so there's this extra thing here, which is dot allows you to access a data member. And if we accessed x, we're all pretty cool with that. But now we're accessing a pointer, and it happens to be a function pointer. And then we happen to be able to put parentheses on the end to invoke the function because it's a function pointer. Okay, so does this help or hurt?
This definitely helps.
Good.
confusion is like actually connecting the functions up.
Yeah.
When compiling, it likes to put underscores in front of every function.
Yeah.
Is there some interesting thing?
That's its own internal stuff, so I'd ignore the underscore. So I mean, in terms of connecting them up, like for example, if I had a rectangle get area function, which you guys all should have from 2H, then, you know, return width times height, or whatever, right? Then as I instantiate my shape, and of course, you're going to use initialize functions to do this, but I could just say s get area equals rectangle get area. And you know, let me tell you, if I do this, I think both of these are going to print -1. We'll see, right? What's that? Rent-tangle? Is that what you guys are? Is that okay? Let's see. I haven't practiced ahead of time. Not good. So it says assigning. Yeah. So that's a problem. Is I said rectangle get area, but putting these parentheses was very problematic because that's saying call rectangle get area. And so what it's doing is saying, oh, you have a function. You want me to invoke this function. I'll return a double. So then say you're assigning a double to a pointer to a function. So that was bad. I need to actually say, I want you to set it equal to the function. Well, as soon as I add those parentheses, just trying to invoke it. Ryan?
And so you're basically like assigning the function to the data member. And then later on you're passing it as parameters.
So it turns out that this right here, rectangle get area, is also a pointer, even though we haven't thought of it in that terms all term, right? And so you're assigning one pointer to another pointer. And this pointer here, the get area, happens to be a data member of a struct. Okay, so let's see if I can get this to compile. We had 4 errors. That's not good. Oh, but look at that. The other ones are easy. So include standard io.h, include, what was the other include I needed? Null. So that means I needed standard lib. And if we compile, we should get -1 twice, and we do. Okay. Seth?
Could you explain just like one more time the line that's
The line that's totally magical?
double get area of width?
Yeah, this one right here? Good. So if we had double star y, we'd all be fine with that. That says this is a data member, which is a pointer to a double. This line right here says this is a data member, which is a pointer to a function. So we had the pointers to functions, the function pointers, and you know we didn't love it. But this is just a function pointer, but it's a function pointer that is a data member. And a function pointer is 8 bytes like any other pointer.
So is get area defined somewhere else, or is that us?
Yeah, good. So this one right here is saying a shape better have a pointer to this function get area, right? And then we actually made an implementation which is rectangle get area. And in your 2H, you have 3 of these, a rectangle, a triangle, and a circle, right? And then down here, I said s get area. So this is saying the data member, which is the function pointer get area, of the struct s, which is of type shape, set it equal to rectangle get area.
Okay, so get area in next to the double is really just like a placeholder name per se, and we're setting it equal to the function we actually want to do.
It is, whoops. I mean, whenever I have a pointer data member like this, and then, you know, I just say like s dot y equals null, right? So it's just setting a pointer data member, but in this case, we're setting the pointer data member to a function which happens to be a pointer. Other comments? Okay, good. So we're going to stop the video.